Introduction.
Hi Pooja, are you free? Can I ask you something?
Yes, Ritu, I'm free. Ask anything.
There is a family in which every female of each generation has exactly 2 daughters.
Okay, then?
I have to find the number of females in each generation. Is it possible?
Yes, it is possible, if the generation number is known. First generation, 1 female. Second generation, 2 females. Third generation, 4 females.
Wow, that was so simple.
Do you know what do we call such progressions? No. Such a progression is a geometric progression. Come, I will tell you more about this. Objectives. At the end of this lesson, you will be able to define geometric progression, explain general term of a geometric progression, explain sum of n terms of a geometric progression, learn geometric mean, understand relationship between arithmetic mean and geometric mean, learn sum to n terms of special series. Definition. A geometric progression or GP is a sequence where each new term after the first is obtained by multiplying the preceding term by a constant r called the common ratio. Let us consider a GP with first non-zero term a and common ratio r. A1 is equal to a. A2 is equal to a into r. A3 is equal to a into r square. A4 is equal to a into r cube, and so on. In general, the expression for GP is a into r, a into r square, a into r cube, up to a into r raised to power n minus 1, a into r raised to power n, and so on, where r is equal to an by an minus 1. Example: 1, 2, 4, 8, and so on, r is equal to 2. 1, 1 by 2, 1 by 4, 1 by 8, and so on, r is equal to 1 by 2. 1 by 4, minus 1 by 2, 1 minus 2, 4, and so on, r is equal to minus 2. Nth term of GP. The nth term of a GP is given by an is equal to a into r raised to power n minus 1. Finite GP is given below. Infinite GP is given below. The series a plus ar square plus so on till plus ar raised to the power n minus 1 is called a finite series, and the series a plus ar square plus so on till plus ar raised to the power n minus 1 so on is called an infinite series. Example: the 7th term of a GP is 8 times the 4th term. Find the GP when its 5th term is 48. Solution. Given that A7 is equal to 8 into A4, it implies a into r raised to power 6 is equal to 8 into a into r cube. It implies r cube is equal to 8 is equal to 2 cube. It implies r is equal to 2. Also, a5 is equal to 48. It implies a into r raised to power 4 is equal to 48, or 16 into a is equal to 48. It implies a is equal to 3. Hence, the required GP is 3, 6, 12, 24, and so on. Sum of the n terms of an GP. Suppose that we want to find the sum of the first n terms of a geometric progression. What we get is Sn is equal to a plus a into r plus a into r square plus a into r cube up to a into r raised to the power n minus 1, and this is called a geometric series. Now the trick here, to find the sum, multiply by r and then subtract. We get Sn minus Rsn is equal to a minus ar raised to the power n. Now divide by 1 minus r as long as r is not equal to 1 to give Sn is equal to a into 1 minus r raised to the power n whole upon 1 minus r. So the sum of the terms of a geometric progression gives a geometric series. If the starting value is a and the common ratio is r, then the sum of the first n terms is Sn is equal to a into 1 minus r raised to the power n whole upon 1 minus r, provided that r is not equal to 1. Example: find the sum of the geometric series 2 plus 6 plus 18 plus 54 plus and so on, and there are 6 terms in the series. Solution: for this series, we have a is equal to 2, r is equal to 3, and n is equal to 6. So, Sn is equal to a into 1 minus r raised to the power n divided by 1 minus r. By substitution and calculation of the values, we get 728. Example: find the sum of the geometric series 8 minus 4 plus 2 minus 1 plus and so on, and there are 5 terms in the series. For this series, we have a is equal to 8, r is equal to minus 1 by 2, and n is equal to 5. So, Sn is equal to a into 1 minus r raised to the power n divided by 1 minus r. By substitution and calculation of the values, we get 11 by 2. Geometric mean, GM. It is the nth root of the product of n numbers. That means you multiply a bunch of numbers together and then take the nth root, where n is the number of values you just multiplied. Let g be the geometric mean between two numbers, a and b. So, a, g, b are in GP. G by a is equal to b by g, or g square is equal to a into b. Therefore, g is equal to square root of a into b. If any two positive numbers are given, then we can insert as many numbers between them to make a GP sequence. Let a and b be any two given quantities, and let g1, g2, g3 up to gn be n geometric mean to be inserted between a and b, so that a, g1, g2, g3 up to gn b will be in GP. Let r be the common ratio. Total number of terms including a and b are n plus 2. The last term b is equal to a into r raised to power n plus 1. G1 is equal to a into r is equal to a into b by a raised to power 1 by n plus 1. G2 is equal to a into r square is equal to a into b by a raised to power 2 by n plus 1. So on. And Gn is equal to a into r raised to the power n is equal to a into b by a raised to power n by n plus 1. Hence, the n geometric means are. These can be inserted between a and b. Example. Insert two numbers between 3 and 81 so that the resulting sequence is GP. Solution. Let G1 and G2 be two numbers between 3 and 81 such that the series 3, G1, G2, 81 forms a GP. Let a be the first term and r be the common ratio of the GP. Therefore, 81 is equal to 3 into r cube. It implies r cube is equal to 27. Therefore, r is equal to 3, taking real roots only. For r is equal to 3, g1 is equal to a into r is equal to 3 into 3, which is equal to 9. g2 is equal to a into r square is equal to 3 into 3 square is equal to 27. Thus, the required two numbers are 9 and 27. Example: the sum of the two numbers is 6 times their geometric mean. Show that numbers are in the ratio. Solution: let the two numbers be a and b. Geometric mean equals to square root of ab. According to the given condition, a plus b is equal to 6 into square root of ab. Let it be equation 1. It implies square of a plus b is equal to 36 into ab. Also, square of a minus b can be written as, and a minus b is equal to 4 into square root of 2 into square root of ab. Let it be equation 2. Adding 1 and 2 we obtain, substituting the value of a in equation 1, we obtain a by b is equal to 3 plus 2 root 2 divided by 3 minus 2 root 2. Thus, the required ratio is relationship between AM and GM. Let A and B be two real positive and unequal quantities. Then, arithmetic mean is equal to A plus B divided by 2. Geometric mean is equal to square root of AB. Thus, we have arithmetic mean minus geometric mean is equal to a plus b divided by 2 minus square root of ab. And on solving, it is found that the difference greater than or equal to 0 and a is greater than or equal to g. Example: if am and gm of roots of a quadratic equation are 8 and 5 respectively, then obtain the quadratic equation. Solution: let the root of the quadratic equation be a and b. According to the given condition, arithmetic mean is equal to a plus b divided by 2 is equal to 8. It implies that a plus b is equal to 16. Let it be the equation 1. Geometric mean is equal to square root of ab is equal to 5. It implies ab is equal to 25. Let it be equation 2. The quadratic equation is given by x square minus x into sum of roots plus products of roots is equal to 0. X square minus x into a plus b plus ab is equal to 0. X square minus 16x plus 25 is equal to 0 using equation 1 and 2. Thus, the required quadratic equation is x square minus 16x plus 25 is equal to 0. Sum to n terms of special series. The sum of first n terms of some special series, namely sum of the first n natural numbers, sum of the squares of the first n natural numbers, sum of the cubes of first n natural numbers. Example: find the sum of n terms of the series. Solution: rth term of the series is equal to sum of n terms equal to summation from r is equal to 1 to n of r cube plus 4 times of summation from r is equal to 1 to n of r square plus 3 times of summation from r is equal to 1 to n of r, which is equal to. On solving, we get n into n plus 1 by 12 multiplied by 3n square plus 19n plus 26. Did you know? Harmonic progression. A sequence is said to be in harmonic progression if the reciprocals form an arithmetic progression. Example: 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. 1 by 10, 1 by 7, 1 by 4, 1, minus 1 by 2, and so on. In general, the expression for HP is as follows. Harmonic mean. When three numbers are in HP, the middle term is called harmonic mean between the other two. Let H be the harmonic mean between two numbers A and B. So, A, H, B are in HP, or 1 by A, 1 by H, 1 by B are in AP. Therefore, H is equal to 2AB divided by A plus B. Summary. Let us summarize what we have learnt. A sequence is said to be a geometric progression or GP if the ratio of any term to its preceding term is same throughout. This constant factor is called the common ratio. Usually we denote the first terms of a GP by A and its common ratio by R. The general or the nth term of GP is given by the sum Sn of the first n terms of GP is given by the geometric mean of any two positive numbers A and B is given by, that is, the sequence AGB is GP.